We're doing absolute inequalities. It's no big deal. These aren't bad. It's just an extension of compound inequalities. I don't know if there's going to be any challenging problems. We'll see. Maybe I spoke too early and there's going to be some really challenging problems, but let's give it a try. I got the absolute value of x is less than or equal to 3. This is a conjunction, so we can say the distance from 0 is between -3 and 3. So again, absolute value means distance, and we want the distance to be less than 3 from 0. That's going to be any number between -3 and 3. There's a solution. We're doing interval notation. This would be -3, 3. Done with that problem. Moving on to the next. Problem number 2. Now we're doing the absolute value. So we want the distance greater than 0. I want the distance greater than 0. Wow, this is a weird problem. This is x is greater than 0 or x is less than 0. Would it give us the distance from 0 to be 0? Wow, that was a weird problem. On a graph, this is going to look like 0 here, and we want any values greater than 0 or any values less than 0. That's what the graph looks like. In terms of interval notation, this is going to be -infinity to 0, union 0 to infinity. That's a weird problem for number 2, but I'm going to continue. It's there for a reason, I think. Number 2. Now we have number 3, that is the absolute value of x is less than -5. No matter how hard we try, the distance from 0 can't be a negative value. So this is no solution, empty set, some version of no solution. We can't solve that. Number 4, that's weird. That was a weird one too. This is kind of a weird worksheet. X plus 3 is equal to 3. That means x plus 3 equals 3, or x plus 3 is equal to -3. Again, we want the distance from, well, I guess it's in the inside. Yeah, we'll say the whole thing is the distance from 0. We want the distance from 0 to be 3, or we want the distance from 0 to be, we want the distance from 0 to be 3. That happens at 3 and -3 on the number line. All right, solving each equation, you get x is equal to 0. Or x is equal to -6 as my answers. I don't know. You'd write this in interval notation. I think they just have it as this thing. It's a weird worksheet. 5. All right, 5. We're moving along though. We're trucking along. We have the absolute value of 3t minus 1 is less than or equal to 2. Again, we want the absolute or the distance from 0 to be less than 2. Those are going to be all the numbers in between -2 and 2. So we can say -2, 3t minus 1 is less than or equal to 2. And then I'm going to solve this, but I'm going to keep it in like the condensed version of it. I'm going to add 1 to everything to get rid of that 1 in the middle. And I get -1 is less than or equal to 3t, which is less than or equal to 3. I'm going to divide everything by 3. I get -1 is less than or equal to t, which is less than or equal to, which is less than or equal to 1. And I get the answer -1 to 1. I'm sorry, -1/3. That's 1/3. -1/3 to 1 as my answer. That's not bad. That's not bad. All right, on to 6. Yes, 6. So 6 is the absolute value of 1 minus x over 3 is greater than or equal to 2/3. Yeah, I think so. What does this mean? Well, now we want the distance greater than 2/3. When does that happen? That happens when 1 minus x over 3 is greater than 2/3. And at the same time, or 1 minus x over 3 is less than -2/3. Solve each equation. I don't know. I'm going to solve this. Maybe I'll move over to the 1. Maybe multiply both sides by 3. I don't know. Maybe multiply both sides by 3. 3 minus x is greater than or equal to 2. Move over the x, I guess, and move over the 2, so that'd be 1. So I get 1 is greater than or equal to x, or x is less than or equal to 1. When I solve this guy over here, similar fashion, I'll multiply both sides by 3. I get 3 minus x is less than negative 2. I'll move the x over. At the same time, I'll move over the 1. I feel like I'm doing something wrong here. So this would be 5 is less than x, or if I want x is greater than 5. I'll write this as interval notation. This is negative infinity to 1, inclusive, union 5 to infinity as my answer. Let's check the answer. It looks good. On to 7. I think this is going to get hard, but we'll see. Let's see, 0 is greater than or equal to 4x minus 7. This is a weird problem too. I don't like this. Don't like this. You don't even have to do anything here. You know, to be honest, that other one, 2. Okay. On this one, no matter what you put in absolute value, because we're talking about distance, it's always greater than or equal to 0. Like, you don't even have to solve this. It's always going to be either a positive number or 0. This is all real. So everything's going to work. Negative infinity to infinity is going to be it. Like, I wouldn't even do any work. Do we want to do work? I kind of don't want to do work. Otherwise, I feel like a robot. I imagine if you separate these and then you solve each one, you get the exact same answer. It'd probably be something like overlapping, like this kind of relationship, like where you have a number. I don't know what the number would be, but like, let's just put A and let's put B. You'd have this kind of relationship where like the numbers overlap, like all of them. And this is going to be an OR statement. It's going to be a disjunction. And you're like, oh, okay, I get all of them. But just looking at that, you can get an answer. You don't actually have to work it out. Number 8. Let's see. So this is the absolute value of, it's hard to read, t minus 2 over 4, which is less than or equal to 1/2. All right. Again, I'm solving this guy. Try my best. This is a conjunction because we're talking about less than, something in between two things. So I'll say negative 1/2 is less than or equal to t minus 2 over 4, which is less than or equal to positive 1/2. I'd multiply both sides by 4. That seems the easiest. So I get 2 is less than or equal to t minus 2, which is less than or equal to 2. And then I add 2 to everything. So when I add 2 to this guy, it's going to be 0. So I get 0 is less than or equal to t, which is less than or equal to 4 when I add 2 to the other side. What does this interval look like? This is from 0 to 4. Boom, done. Yep, it's correct. On to 9. Doing well. I'm doing well. 9, I get the absolute value of x plus 5 minus 3 equals 1. This is the absolute value of x plus 5 equals 4. I get x plus 5 equals 4, or x plus 5 equals negative 4. I want the distance to be 4 from 0. And so then I get answers x is equal to negative 1, or x is equal to negative 9. They just wrote the answers, negative 9 and negative 1. All right, on to 10. On to 10. So I get the absolute value of 2x minus 1 is 2x minus 1 plus 3 is less than or equal to 6. In solving this, this is the absolute value of 2x minus 1 is less than or equal to 3. Again, I want the distance to be within 3 units. So that means I can do negative 3 is less than 2x minus 1 and 3, like this. And then I solve each one. I'm going to add 1 to everything. So I get negative 4 is less than, add 1 to everything. I'll get negative 2. Negative 2 is less than or equal to 2x, which is less than or equal to 4. So I get negative 1 is less than or equal to x, which is less than or equal to 2. And so that's correct. My sub-interval, or my interval is negative 1 to 2. Perfect. On to 11. It's not bad, dude. I'm like making really good time, but maybe I'm rushing. Want to go home for the day or something? Maybe. Okay, so this one's a little bit harder. Okay. So on this next one, and we should have done the same on the last one. I think I was just like going through the steps. 3 absolute 4d minus 7 is greater than or equal to 4. Like the last one, I'm going to solve for the absolute value. So is the absolute value by itself? No. I could move this whole thing over to the right, which might work. I am going to move the 7 over. So I'm going to subtract both sides by 7. So I get negative 3 times the absolute value of 4d minus 7 is greater than or equal to, when I move the 7 over, that should turn into negative 3. And then I'm going to divide both sides by negative values, so be careful. So the absolute value of 4d minus 7 is, that's the absolute value, is less than or equal to 1. There you go. Again, we want the distance to be within 1, so we're going to write a conjunction of negative 1 is less than or equal to 4d minus 7, which is also less than or equal to 1, and then I'll solve away. So when I add 7 to this side, this gives me 6 is less than or equal to 4d, which is less than or equal to 8. And then I divide. So I get 6 over 4, which is less than or equal to d, which is less than or equal to 2. I simplify this expression. 3 halves is less than or equal to d, which is less than or equal to 2. So I get an answer of 3 halves, comma, 2 inclusive. It's not bad. It's not bad. All right, I got some word problems now. Oh, shoots. That's not good. Shoots. Okay, I'm on 12. 12 looks interesting. 7 plus 5 absolute value of c is less than or equal to 1 minus 3 times the absolute value of c. All right, so I'm going to move over the 3c. At the same time, I'm going to move over 7. Oh, yeah, I'm in trouble. When I move over the 3 absolute value of c, kind of treat it like terms. I'll get 7 plus 5 absolute value of c plus 3 absolute value of c is less than or equal to 1. And then when I move the 7 over and combine these two like terms, because they really are like terms, it's like from the distributive property, I get 8 absolute value of c is less than or equal to negative 6. And we have a big problem here because we can't have an absolute value that's less than a negative number. The smallest absolute value could be a 0. So then we get like absolute value of c is less than negative 6/8, but like you're done. Like there's no way absolute value can be less than a negative number. So this is empty set. Like it's not. No bueno. No bueno. Can't do anything. All right, on to 13. Ugh. This looks hard, but let's solve it. I don't want to do this. No, I want to do it. It's just hard. Like I want to do it logically. I can't do it. All right. I'm just going to do it the long way. I'm gonna separate this into a bunch of equations. So one equation, since it's a compound inequality, I can rewrite it as 1 is less than or equal to the absolute value of x minus 2. And that's the problem. We have an and there, so we have to be very careful. And the absolute value of x minus 2 is less than or equal to 3. All right? And then we work on this. We work on that. Now, this is going to turn into an or statement. Or it's going to turn into an or statement, and we're in trouble. Now, I'm just going to try. All right, what or statement is this going to turn into? This says 1 is less than or equal to x minus 2, or 1 is greater than or equal to x minus 2. And I solve each of these equations, right? And then I tried doing number line things. So on this one, this is going to be x is greater than or equal to 3. Just solve that real quick and you'll see that. And then on this one, this is going to be x is less than or equal to 3. Interesting. Wow, I didn't really do anything. I feel like I messed up. Oh, yeah, this should have been negative. Sorry about that. That should have been negative. And now things make more sense. All right. Answering this solution, when I add the 2, this is going to be x is less than or equal to 1. Okay, so then what does this look like? Well, on the number line, here's 1, and it's all values less than or equal to. And then here it's 3, all values greater than or equal. This is a really hard problem. So if you get this, you're like super set. All right, that's one thing. So my solution is either here, it has to be here, and it has to be in the other one. So let's solve this. This is going to be a conjunction. So you're going to say negative 3 is less than or equal to x minus 2, which is less than or equal to positive 3. You'll add 2 to everything. So I get negative 1 is less than or equal to x, which is less than or equal to 5. And then this picture is negative 1 to 5. And so we have this kind of thing, right? And so our solution is where these two things overlap. So you got to look at it. And I think ultimately I'm going to like superimpose these graphs on each other. So I think that's going to be easier. So I'm going to put the numbers negative 1, 1, 3, and 5. And if I superimpose these graphs, the first one is going to be everything less than 1. And everything greater than 3. And the second one is between negative 1 and 5. And remember, this is one solution and this is another solution, but we want the conjunction between these two. So where do they overlap? Well, they overlap from negative 1 to 1. Union, they overlap from 3 to 5. And I'm hoping that's our answer. And that's the correct answer. But like, what I would do is I would pick a number in this interval, plug it in, make sure it works, and then pick a number outside this interval. Like, for example, 0 is in this interval. All right, so plug it in, and 2 is in between 1 and 3. This is really saying the distance. We want the distance from 2 to be somewhere between 1 and 3. Distance from 2 to be 1 and 3. Anyways, that's good. It's a good problem. It's just challenging. It's really hard. That's really hard. It's okay if you like struggle with that. All right, on to 14. My last one. And I'm still under 20 minutes. And there was, at least one hard problem, maybe a couple. A device is rated for 120 volts with a tolerance of plus or minus 5%. For what voltage will it operate safely? I don't know. I don't know if they want us to set up an equation. I don't know how to do this with the algebra. Let's see, a device is rated for 120 volts with a tolerance of 5%. What voltage will operate? I mean, it's just logical. I want to do this as an absolute value problem. Okay. I'm assuming like the equation they want us to, like we want the distance from 120 to be less than or equal to, I'm guessing, less than or equal to 5% of 120. I think that's what they want, and that's an of. But I don't know if I do this mathematically. I don't know. I just calculate the upper range and the lower range. Okay, so we need to calculate a percent of 120, specifically 5%. So we'll calculate 5%. So 0, 10, 5, 6, maybe, if I did that right. Awkward.
Ryan Algemont, report to the main office. Ryan
All right. Anyway, so this is going to be 6. This is like how much our tolerances is in volts. And we want to do plus or minus this value. So our smallest one, we would say 120 minus 6. Again, on the number line. If here's a 120, we want our tolerance to be that way by 6 and that way by 6. So you add and subtract by 6. So what are these values going to be? It's going to be 114 and 126 as our answer. But I guess they want you to do it like as an absolute value. And then write an equation. We want the tolerance to be within 6 units, and then solve it. But it wasn't very interesting. All right. Anyways, 21 minutes. That's not bad. It's not bad. Shoot for 20. That one problem was hard. I liked it though. You'll see it again.